I am Stephanie Grace Siton. In this video, I'll be sharing to you what I learned in hyperbolic geometry. To find a harmonic conjugate of u of xy equals y, let's go ahead and work it out. So it's asking us for a harmonic conjugate of u of xy equals y. In other words, it's asking us to find a function b, which is equal to u plus iv is analytic. So in other words, it's asking us for the Cauchy-Riemann equations to hold and for all of the partials to be nice and continuous. So to do this problem, we're basically going to compute the Cauchy-Riemann equations and use u and v and then solve for v. Before we do that, let's compute the partials of u. So del u del x, that's simply going to be 0, and del u del y, that's 1. So we want the Cauchy-Riemann equations to hold for u and v. So we want del u del x to be equal to del v del y. And we also want del u del y to be equal to negative del v del x. So now, we'll carefully write down what this means. So this means that del u del v del y, rather del v del y is equal to del u del x, and del u del x is equal to 0. It also means that del v del x is equal to negative del u del y, right? We can just simply multiply by negative 1. So this should be equal to negative 1. And now, we have to use this equation and solve for v. So to do that, we just pick any one of these and integrate. Let's just take the first, and we're going to integrate with respect to y. So v of xy will be, we get a constant. In this case, the constant is a known function of x. I'll call it little g. And then, now, we have to use this other equation here, this other derivative. So we'll take the partial of b with respect to x, that's equal to g prime of x, and then we'll set it equal to negative 1. If we integrate this, we get the j of x is equal to, let's see, negative x plus a constant, and that's it. So v of xy is equal to negative x plus c, and there is our harmonic conjugate. Let's proceed to Pappus theorem, but before that, I will show to you my previous activity about finding the centroid. The centroid is 0 and 14 over 5. Theorem of Pappus say, theorem of Pappus requires a region R to be this dark. Second, we need a line not intersecting R. The theorem provides a formula for computing the volume of the region R rotated about the line L. The theorem is d times a provides the volume. What are these quantities d and a? The quantity d is the distance the centroid travels about the line. The centroid will trace out a circle. The formula for circumference is 2 pi r. That's what d is. The quantity a is the area of the region R. Next, plugging that in, we can write volume B by the theorem of Pappus is 2 pi Ra. Recalling that R is the distance of the centroid to the axis of rotation. Find the volume of the solid generated by revolving the region bounded by the parabola y equals 4 minus x squared, and the horizontal line y equals to revolve that region about the x-axis. Good. We're going to apply the theorem of Pappus. Given that we know the coordinates of the centroid since we want to revolve about the x-axis, we look at the y-coordinates of the centroid and let that provide the radius of the axis of rotation. In other words, little r is y bar 14 over 5. From our previous video, we computed the area of the enclosed region as 8 over 3 rad 2. Now, to finish our problem, it's simply plugging in the value of a and the value for a. We can clean that up and simplify to get 224 over 15, multiplying rad 2 and pi. And that's it, we've computed the volume. Thank you for listening. I hope you've learned more about harmonic conjugate and theorem of Pappus. Thank you.